All right, first question. Point moves along a curve. This is the curve. In such a way that the y value is decreasing at a rate of 4 units per second. So the rate that y is changing is dy dt, and that is decreasing, so it's a -4. I want to know what is the rate that x is changing at, so I'm looking for dx dt when x equals -1. So we're talking about time rates because we're talking about per second. So when I take the derivative of this, I'm taking it with respect to time, not with respect to x. So this is going to be dy dt equals 12x squared dx dt. And dy dt we said was -4. X we just said was -1. But when I get squared, that just becomes 12 dx dt. And then to get dx dt, you divide the 12 over, so that gives me -1/3, which means that x is decreasing at a rate of 1/3 units per second. Here we have the position. To get the velocity, you just take the derivative, so v of t is just s prime of t, and that's going to be 3t squared minus 18t plus 24. Acceleration is just going to be s double prime, the second derivative, and that's going to be 6t minus 18. Where the object is at rest is where the velocity equals 0. So I'm going to take my 3t squared minus 18t plus 24, set equal to 0. Factor out a 3, that becomes 8. And then that is 3t minus 4, t minus 2, yeah. So then at t equals 2 and t equals 4 seconds, it's at rest because velocity is equal to 0. Is the object speeding up or slowing down at t equals 1? So first of all, find the velocity at 1. Velocity at 1 is 3 minus 18 plus 24, which gives me 9. Acceleration at 1 is 6 times 1 minus 18, which is -12. So that means that it's slowing because the v of 1 and a of 1 are opposite sides. The absolute maximum, so first of all, find your derivative so that you can find the critical numbers. Right, set your derivative equal to 0. So critical numbers of x equals 0 and x equals 1. Now I need to actually plug in, find f of 0, find f of 1, and find f of -2 and f of +2. So then you just go to your calculator, you plug in. I got 7, 6, -21, and 11. So my maximum is 11, and it occurs at x equals 2. So here we've got a limit question. So you'll notice that it's sine of 0 over 5x, which would become 0 when you take the limit. That's 0 over 0. This is L'Hopital's. It says to act as if this was for your response. So if you wanted to get all the points on this part, you'd have to show the top and the bottom limit going to 0. So the limit as x approaches 0 of sine of 4x is just sine of 0, which is 0. The limit as x approaches 0 of 5x is obviously just 0, right? 5 times 0. And then sine of 4x and 5x are continuous and differentiable. They're continuous and differentiable everywhere because sine just looks like this. 5x is a line, so obviously continuous and differentiable. So then by L'Hopital, you can say LH or L'Hopital. Doesn't it's not like spelling matters. That's just the same as derivative as x approaches 0 of this, or sorry, the limit of the derivative, which would be cosine of 4x times 4. Derivative of 5x would be 5. So then, now we take the limit. So cosine 4, cosine of 0 over 5. Cosine of 0 is just 1, so this is just 4 over 5. But the points there, you would be getting points for doing like the top and bottom limit both show 0. That is continuous differentiable, and then applying L'Hopital to get your answer. Here, pretend there's like multiple choice. You don't have to show how they work. So we plug in e to the 0 minus 1 minus 0. That's 1 minus 1, which is 0 over 0. So then we're going to take the derivative. That's the same as the limit as x approaches 0 of e to the x. Minus 1 goes away, right? That's just derivative will go away. That's negative x, which is plus x, so derivative would be plus 1. over derivative of x is 1. So then this is e to the 0 plus 1 over 1. 1 plus 1 over 1 is 2. Tangent of 0, so let's look. Tangent of 0, tangent is sine over cosine. Sine is 0 over cosine of 1, so this is just 0 over 0. So I'm going to take the derivative for L'Hopital's. This is just secant squared of pi x times pi over derivative of x is 1. Secant squared of 0. Secant is just 1 over cosine, so this is cosine of pi x. Like this. All I did is replace secant with 1 over cosine. Cosine here is 1, so this will just go away, and then you've got pi left. Alright, we've been given position, and we're trying to find velocity t, or the velocity at time t, so x prime is my velocity, and that's going to be pi minus, derivative of cosine is negative sine, so that becomes plus sine of pi t, and then chain rule multiplied by pi. I'm going to rewrite this as pi plus pi sine of pi t. Right, your acceleration is just the second derivative, or the derivative of the velocity, which derivative of pi, that's just a number, so that goes away, 0. And then we've got the pi derivative of sine is cosine of pi t, and then I'd still need to multiply by derivative, so then that is just 2 pi's, which is pi squared. Right, they're being multiplied, not added. When is the particle at rest? So particle is at rest when velocity equals 0. So I'm going to set my pi plus pi sine of pi t equal to 0. And then I'm going to subtract the pi over, because we're trying to get t by itself. Now I'm going to divide the pi, and that leaves me sine of pi t equals negative 1. Look at your unit circle. Where sine is negative 1 is down here. This is pi, this is 3 pi over 2. So I want this inside to be 3 pi over 2, which means I want the time to just be 3 halves. Because when I plug in 3 halves right here, then I'm multiplying by pi, so it'll become 3 pi over 2. At t equals 5/4, is it speeding up or slowing down? So you need to find v of 5/4 and a of 5/4. Specifically, we really just need to know the sign, right? We don't need the actual value. We just need to know is it positive or negative. So think about 5/4 is past the pi. It's right here. The over 4s are really easy. They're all root 2 over 2s. And this one is actually both negative because the x is negative and the y is negative. I'm on the left and down. Okay, so we're going to plug in. This one is pi plus pi. Sine of what I'm looking at, which is negative root 2 over 2. And then the acceleration is pi squared times this cosine, which is root 2 over 2. Now this is obviously just a negative value, so this is less than 0. This one is negative, this one is positive, so whether it's positive or negative just depends on which is bigger. Pi by itself, or pi times this fraction, root 2 over 2 is less than 1, so that means that the pi is the bigger term. Pi minus not as much as itself means it's still positive overall. And then your answer is that it's slowing down because v of 5/4 and a at 5/4 are opposite signs. Now it's not enough to just say this, right? You have to show the work showing that it's positive or negative, because otherwise you would just have a 50-50 shot of like, yeah, it's speeding up because they're the same sign, or slowing down because it's opposite signs, but you need to actually show the work. You won't get the credit. Here I have given you the derivative. So I'm going to make a number line for f prime. I know I've got a 0, I've got negative 1, 2, and 3. Alright, so these are actually even values, so I actually don't need to check across negative 1 or negative or positive 3. These are the two where the sign will change. So in anything I put in, those are going to be positive because they have even power, so I'm really just looking at these two terms. If I plugged in negative 2, that's negative, so they multiply to a positive. If I plug in negative 0.5, negative, still positive, which I knew it wasn't going to change. I don't know why I checked it. If I plugged in 1, that's positive. 1 minus 2 is negative. Positive times negative is a negative. And then if I plugged in 3, that would be positive, positive, and I don't need to check because I already said it wouldn't change over these two. So the number of maximums where it goes from positive to negative is just this one. There's one of them at x equals 0. And the number of minimums where it changed from negative to positive is just 1, and it's at x equals 2. But I just wanted how many I have. Spherical snowball. The volume is increasing at a rate of 8, so that's dV dt is positive 8 inches cubed per minute, or feet cubed per minute. Find the rate of change of the radius, so dr dt equals my unknown when r equals 4. This is my volume. I'm talking about related rates, so take the derivative with respect to time, 4 pi r squared dr dt. This is 8 equals 4 pi 4 squared. dr dt is what I'm looking for. So that's 4 pi 16 dr dt. I canceled this out and it became a 4, and then I divide over, so that becomes 1 over 8 pi. A particle moves along a straight line. This is the position. Find the maximum velocity. So first, let's find what the velocity is. So v of t is 4t cubed minus 12t squared plus 12t. All right, now this is what I want to find the maximum. Find the max of. If you want to rewrite this and just call it f, right? If you were to find the maximum of f, first thing you would do is find the critical numbers of f. So find v prime, set it equal to 0. So you've got 0 is 12t squared minus 24t plus 12. Factor out of 12, and you get t squared minus 2t plus 1. T minus 1, t minus 1. So then your only critical number is t equals 1. So I need to find the velocity at 1. But I also need to find the velocity at 0 and the velocity at 3 because I need to check the endpoints. Actually, I didn't write this down. I'll show you in the calculator in case you forgot how to do it. That's not what I meant to do. Okay. So first of all, you go to your y equals, and I'm going to type in what I need to plug into, which is the velocity. So 4x cubed minus 12x squared. Oh my god. You guys can skip through this part. There we go. 12x squared plus 12x, and then X it out, and now to bring it up, you just hit the green F4 button, and then of 0 of, oh my god, oh dear, oh dear. Okay, v of 0 is 0, v of 1, wow, you guys can just skip this part, oh my god, is 4, and v of 3 is 36. So I wanted to know what the maximum velocity is. So the max velocity is 36. And when or where it is at t equals 3. All right, here we've got implicit. I want to show that the dy dx is equal to this. So first step is like take the derivative with respect to x. So that becomes 2 plus 2y dy dx minus, all right, I'm taking the derivative of x, y. So product rule, take derivative of x, that's 1 with the y. And then I'm still taking the derivative of this, so that negative sign goes with the x dy dx. Equals 0. Now I'm going to add the y and subtract the 2 over. So I've got 2y dy dx minus x dy dx equals y minus 2. And then now I'm going to factor out the dy dx. 2y minus x equals y minus 2, so then dy dx equals y minus 2 over 2y minus x. No, where's my red pen? Whatever. And then make sure that they actually look alike, right? There's no point showing that two things are equal if you didn't show that they're exactly equal. All right, and then finding the tangent line, so tangent line is y minus negative 1 equals slope x minus 1. Now we just need to find the slope, so we're going to plug in. Y was negative 1 minus 2, 2, negative 1 minus 1. So that's negative 3 over negative 3, which is 1. So then it just has a slope of 1, and that is the equation of my tangent line. Volume of cube is increasing by 10 this. So this is dV dt is 10. find the rate that the surface area is changing. So because this is talking about like sides of the cube, I'm going to call the surface area dA dt. So let's call that A. And then when the side is 5. So first of all, let's use dV dt to get ds dt. So take the derivative of the volume equation, that's 3s squared ds dt. And then I can plug in, this is 10 equals 3, 5 squared ds dt. So that's 10 over 75 equals ds dt. That can simplify to 2 over 50. I think so. And then now I want to find dA dt, the area's derivative. So dA dt equals 12s ds dt. So that's 12 times 5 times ds dt you just said was 2 over 15. Let's think. That becomes a 3. That's a 4. So this is 8. dA dt. So the area is changing at a rate, or increasing at a rate of 8 centimeters squared per minute. Alright, we've got position. We want to know where it's moving to, when it's moving to the left, when it's moving to the right. So that's when velocity is positive or negative. So first find the velocity. So v of t is 6t minus 1. Set this equal to 0. T equals 1/6. So then you look at your velocity, right? It's changing signs, or it's 0 at 1/6. If I plug in anything less than that, I get a negative. If I plug anything more than that, you get a positive. So then it's moving to the left for t less than 1/6. And it's moving to the right for t greater than 1/6. Technically between 0 and 1/6, because you can't have a negative 10. Alright, here I've again been given the derivative of the function, and I want to know what must be true. So I'm going to first of all, f prime, I'm going to make this x minus 1, x plus 1, h of x. So I know I have a critical number at 1 and negative 1. This is my f prime. And I'm plugging in for the signs. So think about if I plug in 0, right? This is negative, this one's positive. And then it says right here that h of x is negative for all real numbers. This is negative no matter what. Negative times negative would actually be a positive right here. If I plugged in 2, that would be positive, positive, this would still be negative, so that's negative. If I plugged in negative 2, this is negative, this is negative, this is negative, so that becomes negative. Negative, positive, this is a minimum, positive, negative, this is a maximum, so minimum at x equals negative 1, and max at x equals positive 1. Another implicit, so take the derivative with respect to x, 2x plus 8y dy dx minus 4 plus 16 dy dx equals 0. Add the 4 over, subtract the 2x, so 4 minus 2x, factor out. This is 8y plus 16, and now I've got my dy dx. Alright, to find where the tangent line is vertical, that's where it's undefined, so you set the bottom equal to 0, and you get the y is equal to negative 2. Alright, now I need to find the, so I know I have like something negative 2, right? I need to find the x value that goes with that, so I'm going to plug in and find the matching x value. Plus 2. Alright, that is 4, which is 16. That is minus 32 equals negative 4. That becomes negative 16. Add over, that's negative 12. Equals 0. Now I factor, that's x minus 6, x plus 2. So x equals 6 and negative 2. So you've got 6, and then you've got negative 2 with the same y value. So 2 points right there. Alright, now where it's horizontal is where the slope equals 0, so the top equals 0. 4 minus 2x equals 0, so x equals 2. And then to, right, 2, what's the y value? Plug in 2 squared plus 4y squared minus 4 times 2. I'll not talk now. That's negative 8 and 4, but then when you add this 4 over, they cancel out. So you've got 4y, y plus 4 equals 0, y equals 0 and negative 4. So both have an x value of 2. One is at y equals 0, one is at y equals 4. So this is where it's horizontal, and these two are where it's vertical. Okay, we've got a function f, and we know that there's a relative minimum here. What do we know about f prime here? Well, at a relative minimum, right, it could look like this or it could look like this. Either way, at the minimum, or not either way, if it exists, then f prime is equal to 0. Does f prime have to exist? No. You can have a critical number at f prime undefined. That's definitely a possibility. Something like this, right? F has to exist if you have a minimum, but the derivative doesn't have to. This is not differentiable at this point because the derivative is different on either side. If f double prime exists, what do we know about it? Well, for a minimum, right, this is concave up, so then f double prime would have to be positive. All right, we've got critical numbers at 0 and 3, and f double prime equals this. Which of these would be a relative max? Which would be a relative minimum? So critical number is like talking about relative maximums and minimums, right, where f prime is 0 or undefined. Now to decide if it would be max or min, normally we do the f prime number line with positive and negative, but I don't have f prime, I just have f double prime. So think about, for a minimum, f double prime is positive, and for a maximum, f double prime is negative. So let's just actually check in. When you plug in x equals 0, that would be negative, so that would be concave down, which is a maximum. So the maximum is at x equals 0 because f double prime is negative. When I plug in the 3, that's 6 minus 3, which is positive, concave up would be a minimum. So that would be x equals 3 because f double prime is positive. It's concave up, the minimum. All right, we are looking for how many values does the mean value theorem will satisfy the mean value theorem from -2 to 2. So let's go, -2 is right here to +2 is right here. So the average, right, this is my average rate of change. Obviously, I have a positive slope. I want to know how many values of c, how many instantaneous points are going to satisfy that instantaneous point slope is equal to the average rate of change. So I see one here, I see a positive right here, and one right here, so there should be 3. I asked you to actually estimate it. This is like not a good graph to estimate. But if this is 0 and this is -2, maybe like -1.8. I don't know. Here, just negative of 0, so maybe -0.2. And then here, maybe, I don't know, positive 1.8-ish. Not a great graph to estimate from. All right, limit of e to the blah, blah, blah. So first of all, e to the 0 is 1. 1 minus 1 is 0. Natural log of 1 minus 0. Natural log of 1 is 0. So this is 0 to 0. I'm going to have to use L'Hopital's, which is saying that my limit is just the derivative, e to the 2x times 2, over derivative of natural log is 1 over 1 minus x. But then you have to take derivative of the inside. Derivative of the inside would be -1. So this is 2e to the 2x over -1, 1 minus x, like that. And then we're plugging in zeros, that's over 0, that's -1 over 1, which is -1. E to 0 is 1 here, but there's still a factor of 2, so it's -2. Did not leave us much room here. That's okay. The limit of 2 times f of x minus 7, so as x approaches 7, 1, 2, 3, 4, 5, 6, 7. F is 1, 2, 3.5. Yeah, that's exactly the halfway point. So you've got 2 times 3.5 minus 7, that's 7 minus 7, that's 0, and then g of x is going to 0. So this is 0 over 0, I'm going to use L'Hopital's. So that's just saying that this is the limit as x approaches 7 of 2f prime of x over g prime of x. F prime of x when x is 7, f prime is this one, so that's a -1/2. So I've got 2 times -1/2. G prime here is -2, so then this just becomes +1/2 is your limit, equals +1/2. Right, using the graph to estimate the value of c that justifies the mean value theorem for the interval 0 to 8. So let's go to 0 and 8, look something like that. I need to, so I would say somewhere in here and somewhere in here, it's hard to tell. Yeah, maybe a little flatter somewhere in here and here. So let's check. 1, looks like the derivative is 0 there. It's not increasing, not a positive value. 7 is definitely negative slope, not right. 0.5, definitely a negative slope, nope. 8, first of all, it's a negative slope there, and endpoints can't be like the point, so no. And 1.5, yeah, it looks like it would be positive, roughly that one. So that's the value of c that satisfies it, where the instantaneous rate of change is equal to the average, or you can think about it as like the slope of the tangent is equal to the slope of the secant drag.